Hello everyone and welcome to the stream. Today we're gonna continue with the Vulkan tutorial and today we need to add render passes to the graphics pipeline. So you can follow with me on this link, which I will send on the chat, and also if you want to check out the source code, it is freely available on my GitHub, so I also send the link on the chat. So let's see the current status of the project. We just run an exit and print some information. So everything looks okay. So let's see where we were last time. We were creating the shader stages and all the fixed pipeline functionality and configuration. The rasterizer, multisampling, color blending, dynamic state, and actually we ended up creating the pipeline layout, so we can continue from here. Let's see. Before we can finish creating the pipeline, we need to tell Vulkan about the frame buffer attachment that we will be using. We need to specify how many color and depth buffers there will be, how many samples for each of them, and how their content should be handled through the rendering operations. All of this is wrapped in a render pass object. So we're gonna create render pass right before graphics pipeline. Okay. We are doing all of this inline in main, but we'll try to follow along. So we start by defining some attachment descriptions. One for the color attachment, and I guess if we needed a depth buffer attachment, we would create another one. And then we can add subpasses and attachment references. So it looks like we need to create the render pass before creating the pipeline layout, but I'm not entirely sure yet. Let's add it afterwards. So we're gonna have a render pass, which can be initialized as a null pointer. And then we need to call the bk create render pass function. So we do the same as usual. Call the method inside a check macro to check the possible errors. Pass in the device, and then we're gonna create this render pass create info inline. Here where we call the function, we will have to fill in this structure. Which we will do in a moment. Then we also pass null pointer for the allocation callbacks, and we get back the render pass like this. So I'm gonna grab the definition of this function from the Vulkan header locally in my system. So create render pass, and here it is. So let's add it down at the bottom of our external functions. So it takes the device, the pcreate info, the allocator callbacks, and finally it returns the render pass as an output pointer. So we'll need to create this render pass info. So we can add it at the bottom of our struct definitions. And also search for it here. This is render pass create info 2, but we need the one. Okay, so we have the structure type, pnext for adding possible extensions, some flags, the attachment count, the actual attachments, the subpass count, the subpasses, and the dependencies. And we're gonna need to add definitions for all of these. So where do we have the flags? Here. So we can add a new one for render pass create flags, which is just a type def for pk flags. Next, we need to add the bk attachment description. Here it is. So public struct, bk attachment description. I'm gonna copy all of these. And then we just need to adapt it to Rust, basically. and repeat it a few times. Didn't work. So let's try to record the macro again. Start recording, go to the first word, enter pub, space, exit. That was a bit better. So from all of these, we don't have them also, so the attachment description flags go also with the flags. BK format, we already have it. BK sample count flag bits. I think we already have BK sample count flags. We do. So this one, I'm gonna change it to actually be the flags type. Then we have attachment, load up, store up, twice, once for the actual attachment and one for the stencil, looks like. Then we have image layout. So let's go first with the BK attachment load up. Here we have the enumeration, can grab it, and also the store up. And we can add it down at the bottom. And export all of the variants so we can use them directly without having to name the enumeration type. So we do the same for the store up. What else do we have? Okay, now we need the image layout. Is this also another enum? Looks like it is. So let's grab it. And add it down here. Probably we'll need to remove this conditional compilation. something like this, and we cannot have two names for the same value in an enumeration in Rust, so I'm gonna just comment out these last few values. Okay, we're doing some progress. We already have the attachment description. Now we need to work on the BK subpass description. So let's search for it. Here are the flags, and here's the actual definition. So let me add it down here. It has some flags. The attachment count. The input attachments. And the color attachments. The resolve attachments. The depth stencil attachment. The preserve attachment count. Which looks like it's just an array of U32s. So I think we're just missing the attachment reference now. Which is simple enough. So it down here. It contains an attachment and a layout. So are we missing something? Let's try to do cargo check. We forgot to add PK subpass dependency on line 9 to 6. That's right, we missed this one. And this one, what does it take? we just need to format this correctly. And then we need to change U32s. And I missed this one. Now it should auto format for me. So we need pipeline stage flags, access flags, and dependency flags. So let's add them. Pipeline stage flags. I'm assuming all of them are just type defs or BK flags. BK access flags and dependency flags. Do you have this one already? Still getting some errors. On line 127. This needs to be a BK result. And then 2047. Yeah, these ones we cannot have duplicated names, so we need to comment them out. Do I have anything else? Okay. Oops. Okay, now we are only getting compile errors in main. So we can go to main. This should be null mood. And then we need to fill everything in. I'm gonna have this open for reference. So we need pnext, which we don't use, flags, which also we don't use. Then attachment count, we're gonna have one attachment, which is the color attachment. So here in the P attachments, we can add a reference to a BK attachment description. Which we are gonna fill later. Then we're gonna have one subpass. It's not helping me. Which is gonna be dk subclass description. And for dependencies, we are not setting them. Yeah, looks like they are not setting them in the tutorial, so dependency count is going to be 0 and dependencies pointer dependencies is going to be null pointer. So now we need to fill in the attachment description. With all of this. So we have flags. Let me see, this is the color attachment. Flags, we are not using them. Format. The format is going to be the same format as in the swap chain, which in my case was hard-coded. Yeah, we just assert that we have it on the list of supported formats and then we set it. Then we have the samples, which is gonna be 1-bit samples. The load up is gonna be clear, and I think we will need to add these constant definitions. The store up is gonna be store. Then the stencil, load and store, we don't care. And the initial layout is gonna be undefined. And the final layout is gonna be a layout present source. So let's read through this a little bit. We just have a single buffer, color buffer attachment represented by one of the images from the swap chain. The format of the color attachment should match the format of the swap chain, and we're not doing anything with multi-sampling, so we'll stick to one sample. Okay. The load and store ops determine what to do with the data in the attachment before rendering and after rendering. You have the following choices for load. Load, clear, and don't care. So we can preserve the existing contents, clear the values, or we don't care and the contents are undefined. So in this case, we want to clear, when we start a render pass, we want to clear to a predefined color. And for store op, there are two choices. Either we store, so the rendered contents will be stored in memory, or we don't care, and the contents of the frame buffer will be undefined. We want to see the rendered triangle, so we're gonna store. So for the stencil, Load and store operations. We don't really care because our application doesn't use a stencil buffer so far, so that's it. Textures and frame buffers in Vulkan are represented by BK image objects with a certain pixel format. However, the layout of the pixels in memory can change based on what you're trying to do with an image. Some of the most common layouts are color attachment optimal, layout present source, layout transfer destination optimal. We'll discuss this topic in more depth in the texturing chapter, but what's important to know right now is that images need to be transitioned to specific layouts that are suitable for the operation that they're going to involve. They're going to be involved next. The initial layout specifies which layout the image will have before the render pass begins. The final layout specifies the layout to automatically transition to when the render pass finishes. Using layout undefined for initial layout means that we don't care what previous layout the image was in. The caveat of this special value is that the contents of the image are not guaranteed to be preserved, but that doesn't matter since we're going to clear it anyway. We want the image to be ready for presentation using the swap chain after rendering, which is why we use image layout present source as final layout. Okay. Then we have this color attachment ref, which is set where exactly? It's part of the subpass. Okay. So here in the subpass description, we have flags, input attachment. So flags, we don't use them. Then input attachment count. It's gonna be 0. We don't want to read anything from the shader. So this and the input attachment is gonna be no. But we do want a color attachment, right? So we're gonna have one of those and then P color attachment. And this is gonna be a pointer to a BK attachment reference, which we'll need to fill in. This one takes an attachment index, I guess. Yeah. We specify the attachment reference by its index in the attachment descriptions already. So we only have one, so we specify its index as 0. And the layout for this attachment is going to be color attachment optimal. Oops. And that's all we need for the attachment reference. Then I don't think we have any resolve attachments as well, neither depth stencil attachments, so we're gonna set those as null pointers. Preserve attachment count doesn't seem to be used. And it seems that I have a typo here. This should be lowercase, like that. So, probably we're gonna have a bunch of problems now, but let's go through them. P depth stencil attachment, stencil. Yeah, depth stencil. And surprisingly, it compiles. Really? Okay. So we have this monster function call. You have though, did I save? It's weird that it's giving me some in the subpass description, P depth stencil attachment. This looks correct to me. P depth stencil attachment. Yeah, it was just that this was stale. Okay, so the moment of truth. Let's try to run this. And since we are not cleaning it up, I expect to get a validation error. And what do we get here? BK render pass required parameter p create info p subpass 0 p color attachment specified as no. The Vulkan spec states if color attachment. So we have p subpasses, p color attachments specified as no. We specified one, and then we are specifying it, right? So I don't know what is it all about. And it's saying that we have minus something color attachment. Am I missing something? Color attachment ref. That's weird. Maybe I will have to split it out of the main create info struct like they do here. I have substructures for each of them. Let me see. The subpass description again. So it's like it's thinking, like we specified like this, right? But we didn't, we actually specified it. Now we just get an error that we didn't destroy it. It's weird. Did I specify? I want to double check that I have this right. So bk render pass create info. Maybe I did a mistake in the order or something. So s-type, pnext, flags, attachment count, p attachment, of type attachment description, pointer, subpass count, p subpasses, dependency count, p dependencies, then the subpass description has flags. Oh, I'm missing this pipeline bind point. Wow, that was hard to spot. Bind point bk pipeline bind point. Then we have input attachment count, p input attachments, color attachment count, p color attachments, p resolve attachments, p depth stencil attachment, preserve attachment count, and p preserve attachment. Okay, so back to main. In the big case, pass description. We can get rid of this. And we need the pipeline bind point. So what is it set here to? Aha. Pipeline bind point graphics. So right after the flags, we set this. commented out, right? No compilers. Let's give it a run. And yeah, now we're just getting this validation that we are not destroying the render pass. So let's destroy it. It is the last thing we are destroying, so creating, so we should destroy it also last. Here they are doing it in the opposite order. I don't know why, but maybe we can reorder it later if necessary. So this takes the device, render pass, and the allocator. Doesn't return anything, I guess. Let's try to run it. And now we don't get any validation errors. Nice. So let me see the changes that we introduced. Okay, let's commit this. Create render pass and push. Okay, so what do we have next? In the next chapter, we're gonna combine all of the structures and objects from the previous chapters to create the graphics pipeline. Finally, here's the types of objects we have now as a quick recap. Shader stages, fixed function state, assembly rasterizer, viewport and color blending, pipeline layout, the uniform and push values referenced by the shader that can be updated at draw time, and render pass, the attachments referenced by the pipeline stage and their usage. All of these combined fully define the functionality of the graphics pipeline, so we can now begin filling in the BK graphics pipeline create info. So we're gonna start with the function definition actually. So if I go to main, here after the render pass, we can call this bk create graphic pipelines, which takes the device. Let me open this on the Vulkan header. So for the pipeline cache, it says that we can use bk null handle. We don't have it defined, but so can I use just a null pointer, because pipeline cache should be it's just a handle. So yeah, we should be able to pass in just a null pointer. Then we have the create info count, which we're gonna have 1 for now, and then an array of bk graphics pipeline create info, or just a pointer. I'm gonna add it in line as usual. I need to fill in all of this later. Then we have the allocation callbacks, which can be null, and we get back the graphics pipeline, which we need to define first. So this is the basic structure. Now we can go ahead and add this to our bindings. bk create graphics pipelines returns bk result, and it takes the device. I'm gonna have to leave soon, so let's see if I can finish this pipeline cache. Create info count, 32, create infos, const bk graphics pipeline create info, allocator, and we get back the pipelines. Or in our case, just one pipeline. So what are we missing? Graphics pipeline. Let's add it at the bottom. Whoops. Oh man. Okay, here we have the structure. Has a bunch of fields, as usual in Vulkan. But we are almost there, I can feel it. The triangle is about to come, I'm feeling it. We have flags, okay, pipeline, create flags. We have the stage count, the stages. Other stage, create info. Now we should have most of these structures defined. We have the p vertex input state. We have the p input assembly state. We have the tessellation. I don't think we have this one because we don't use it for now. Tessellation, state, create info. So we're gonna have to define this one. Then we have the viewport state, pipeline viewport state create info. We have the rasterization state. We have this one as well. We have the multi-sample state. We have the depth stencil. Don't we have this one? Pipeline depth stencil. State create info. So it looks like we don't have this one. Yeah, right, because we're not using depth or stencil yet. We have also the color blend state. We have the dynamic state. Then we have the pipeline layout, which we created previously. And we have the render pass, the sub pass as an index looks like, the base pipeline handle, and the base pipeline index as an I32. So we are missing the flags, which is easy. And then we are missing the tessellation and the depth stencil. So I'm gonna put them at the bottom. And I'm gonna put a big to do because I need to go soon, so I'm gonna leave it for next day. What is the problem? Complaining about empty types, okay. So just put an empty data. Now we're just missing all of the fields. Now we just need to pass in all the things we created previously. Tessellation. This can be null. The viewport. Which can be viewport state. The rasterization can be rasterizer. The p multisample state can be the multisampling. The depth stencil can be null. The color blend. Then the dynamic state can be null. The layout can be our pipeline layout. The render pass. That we created right before this. The subpass is gonna be 0. The base pipeline handle can be null. And the base pipeline index is -1. So we have everything. Cargo check. Pipeline color blend attachment state. Did I mistype on the color blend decay. Yeah, decay pipeline color blend state create info like this. The input assembly state. That's right, we missed the P input assembly state, which should be input assembly. Anything else? And it is compiling. Let's try to run it. And it just complains that we're not cleaning up the pipeline, so let's quickly add this. Decay, destroy pipeline. Passing the device, graphics, pipeline, and no. Quickly add this to BK. Takes in the device. Takes in the pipeline and the allocator. And that should be all, I think. Compiles, run it. And we don't get any error. So cool, we managed to create the graphics pipeline. Let's add all of these changes to Git. Push. And that would be all for today. So thank you all for watching. I hope you liked the content, and I'll see you next time.